What's up, my stats nerds? Let's talk about the difference between a paired t-test, a regular t-test, and a two-sample t-test. Now, all three of these deal with means, right? So you're going to have some sample, and from that sample, you're going to collect some quantitative data, and then with all those numbers, you're going to get a mean, right? So you're going to get the mean of your sample. Now, a regular t-test, you have one sample, and from that one sample, from each individual, you collect your piece of data, and then you get it all together and you get a mean. You get your sample mean. And what you're trying to do is show that this sample mean provides evidence that the alternative hypothesis is true, hopefully, right? Or maybe you find out you can't show it's true. But that's the idea, one sample. Now, in a two-sample t-test, you have, well, two completely separate samples. So from the first sample, you get a mean. From the second sample, you get a mean. And what we care about is the potential difference between these two samples. And does the difference between these two samples prove that there is a difference in the populations? But again, example of this would be two different populations, sample from each. Maybe you're looking at the mean amount of time boys spent on homework versus the mean amount of time that girls spent on homework. But you got two completely separate samples. You know, you're measuring the same thing, how much time you spent on homework, but two completely separate samples, hence you have two completely separate sample means. Now, in a paired t-test, it might look like you have two samples or two sets of data, but you don't, because that data needs to be paired. So you have two pieces of information. So here's piece of information A, and here's piece of information B. Maybe I threw a ball with my left hand and I threw a ball with my right hand, so I measured the distance on both of them. Maybe I took a test before I did something. Maybe I took a test after. So I have two test scores, but they both come from me. Maybe I measure my blood pressure before something and I measure my blood pressure after. So I have two pieces of information, but they both came from me. And again, anything that creates paired data. Maybe you have one sample of items and you measure them twice. So you have two pieces of information for each piece of data. So again, that's the idea. You have one sample, but from each individual in that sample, you have two measurements, and those two measurements need to go together because they came from the same person, hence they're paired together. So when you're working with this, yes, it might look like you have these two sets of data before and after, but all you really care about is the differences. So it's a mean difference from our sample that we care about. We don't care about the before. We don't care about the after. I don't care about the right hand versus left hand. I care about the difference between my measurements, and I'm going to get all of those differences to get a mean of the differences. Again, here I just have one sample, measured at one time, just get a sample mean, easy. Two sample t-test, it's very clear that I have two separate samples from two separate populations. So I have a mean from one, a mean from two. There's no reason to pair them together. So that's kind of an easy way that you could tell the difference between these three things.